What would it be like to follow an oil spill to its source, faster and cheaper? What would it be like to observe a ship fire from above without endangering a pilot? What would it be like to take air samples to detect an environmental offence without being noticed? Is this possible in the maritime environment through the use of unmanned aircraft? That's the question the partners in the 3I project asked themselves. The Port of Rotterdam, one of the busiest stretches of sea on Earth, where safety and environment are a top priority. The patrol boats and traffic controllers of the Port Authority work hard to keep the port safe, but they may not always be able to respond immediately to all situations. The use of unmanned aircraft in a maritime environment may open a range of new possibilities. No long runways needed, relatively cheap to buy and low maintenance costs. That is where the strength lies for the RPAS, jargon for remotely piloted aircraft systems. In order to keep the sea clean and to ensure a safe arrival in the port, unmanned aerial surveillance may be a useful addition to existing resources. The new possibilities offered by the deployment of unmanned aircraft in any maritime environment are recognized in the Netherlands, the United Kingdom and France. With that in mind, an interregional cooperation has been established. Together, the advantages are being investigated. Partners from each of the 3 countries have come together with a goal to develop unmanned aircraft and surveillance technologies that may lead to cost-effective and flexible means of aerial surveillance in a maritime environment. The resulting project is called 3I. The I's in 3I stand for Integrated Coastal Zone Management via Increased situational awareness through innovations on unmanned aircraft systems. 3I's RPAS, the 2Cs20, is a combination of the strengths of the individual partners and of the end users. 3D printing technology from the United Kingdom to build the aircraft. The man-machine interface from France to operate and control the machine. And the ground station and camera systems from the Netherlands for both controlling and surveillance. European cooperation in the jointly developed aircraft has resulted in a much better system than what each individual organisation could have achieved. The 2Cs20 has been designed and built using the newest method of fast prototyping. Designed on a computer, the aircraft was split into several large components like wings, fuselage and tails. These parts have been largely built with a 3D printer. The main benefit of 3D printing is that the manufacturing needs neither molds nor large tooling machines. The designer's ideas can simply and quickly be converted from a blueprint to an actual prototype. The 2Cs20 contains software that makes it easy to operate. Currently, the unmanned aircraft is controlled from the ground. It will soon be possible to add on to the software. Once upgraded, it will be able to fly autonomously, obviously under supervision, as the current laws and regulations require a pilot in command. Mounted cameras and sensors will enable users to view on the ground what the aircraft sees. And it will go a step further. Coupled with smart software, the aircraft itself will see if the route is safe. It detects static and moving obstacles and can adjust its course accordingly. This sense and avoid principle will deliver an even safer autonomous flight. The 2Cs20 is a modular system. It can be equipped with a wide range of cameras and sensors. Imagine having cameras that are able to survey ships anchored offshore. Imagine having infrared sensors which are able to locate the source of flames on a ship. Imagine having an electronic sensor that can collect and analyze air samples to detect environmental offenses. The complete mission is prepared inside the special 2Cs20 bus. Inside this ground station, the route is programmed and then uploaded into the memory of the aircraft. After the necessary checks, the aircraft is started up, and after warming up, it is ready to depart. The whole mission is subsequently monitored from the ground station. The 2Cs-20 can be fully controlled from the bus. Neither long runways nor control towers are needed. The 2Cs-20 can fly from the quayside or a parking lot. Once in the air, the aircraft will fly its pre-programmed mission. During the flight, all collected data is sent in real time to the ground station inside the bus, and possibly even directly to the desks of the decision makers. After completion of the mission, it lands by itself on the quayside. This year, the 2Cs-20 has made many test flights in the United Kingdom. Overwater demonstration flights were performed in the port of Ramsgate. This was possible due to less restrictive flight safety laws and regulations than those in the Netherlands. Most flights were successful, but some were not, and valuable lessons were learnt. 3i investigates the possibility of deploying unmanned aircraft in a maritime environment. Surveillance and tracking from the air saves time and delivers a good overview. Potentially unsafe situations on the water can be detected earlier and measures can be taken immediately. Large areas can be covered in a short space of time. Remote locations can be reached quicker and cheaper. Environmental offences can be tracked to the source much quicker. The response time to start searching for casualties in the water is much shorter. Preparations to combat incidents can be done more effectively and quicker. Emergency services will have a better insight into the circumstances and can therefore work more safely. The effects on the wider area can quickly be visualized to those who take action. The deployment of an RPAS at sea offers a good opportunity to track down suspects in fast boats. Thanks to an RPAS, there's no escape for drug smugglers at sea. .3i is an EU-funded project of the Interregional Cooperation Programme called Interreg. It is a border-crossing partnership between the countries in the 2Cs region, both sides of the Channel. These include the United Kingdom, France, Belgium and the Netherlands. 2Cs is supported by the European Regional Development Fund of the European Union. One of the main goals of the European cooperation was the integration of a complete system of aircraft, autopilot, flight control software and integrated ground station. This work nears completion, and 3i is almost ready for the next step. Unmanned aviation is flying towards a great future, and the Dutch industry wants to play a leading role. 3i shows that the knowledge is available in-house to make it an economic factor in the 2Cs region. For instance, in the West Brabant area. The high level of safety in manned aviation is due to the many investigations into mishaps. The same goes for unmanned aviation. Thanks to the 3i project, we have been able to contribute to the advancement of flight safety. At the same time, the end users have gained a valuable insight into the possibilities of unmanned aircraft in a maritime environment.